Development Research Group.
And we both were sitting in the same office.
Yes,
yeah.
for
that's how we know each other.
3 or 4 years, I think. He is a chair of the Internet Task Force Global Access to the Internet for All research group, and a member of the Internet Research Steering Group. Sorry. He is part of the Amber Foundation, and they're going to open a lab in Cambridge, UK, pretty soon, and which aims to build the world's largest decentralized telecommunication network using blockchain. He was in the Access Advisory Panel of the United Nations Foundation Digital.
Thanks to Jonathan down there.
He is also in the advisory board of the Ubuntu Power social enterprise focused on providing affordable off-grid energy and internet to underserved community and groups, and a social business incubator in the Democratic Republic of Congo. He is also in the advisory board of the EU Net Commons project, and is also a member of the University of Cambridge Center for Science and Policy.
That's by default that everyone is a member there. Right, so thank you so much. Thanks a lot, Thomas, and thanks for everyone here for attending this talk. It was a bit of a far trip. I don't think I've given an invited talk 7 hours away from my place, but it was nice to come here because my in-laws are here. My wife is from Boston. So I had a pretty good dinner at my in-laws' house last night. So I'm full. Right. So as Thomas introduced, I'm Arjuna Sathiaseelan. So from my surname, you can kind of guess I'm either an Indian or a Sri Lankan. I'm actually a Sri Lankan. I'm not an Indian. You can see a lot of vowels there, so that means I'm a Sri Lankan. So I'm a senior research associate at the Computer Laboratory, University of Cambridge, which is the computer science department there, where I direct the N4D lab, which is a networking for development lab, where we are kind of focusing on looking at technologies for providing internet access in emerging markets. Recently, I'm also a founding member of the AMBER, which is AMMBR, where we are trying to actually build probably the largest blockchain network in the world, especially focusing on emerging markets. And I'm going to talk about what we are trying to do there. And as you said, I'm also the chair of the Internet Research Task Force Global Access to the Internet for All, the Gaia Research Group, which is a standardization arm of the IETF, which is the Internet Standardization Body. And there we are looking at bringing communities, bringing practitioners, and different stakeholders together, where we discuss about the challenges of global internet access provisioning, and we look at solutions, we write proposals, we write papers. Obviously, we do a lot of collaborations. And I think that's where we met. I think I met Jonathan as well. So I'm pretty social, you can see. I'm on Twitter, Facebook, and I'm also on YouTube. I don't know what is there, but I had to fill a line. Right, so just for the context of my talk, to start off with, I thought I will probably go to Democratic Republic of Congo. How many of you know Ijwi? No? No? Nice. So whatever I say makes sense. It's true. Right, cool. So Ijwi is also known as the Forgotten Island. It's an island right in the Lake Kivu, between the borders of Rwanda and DRC. It is an island with 300,000 users, or 300,000 population. Especially in the southern part, you have the largest pygmies groups there. If you had learned geography, and you would have known about Zaire and pygmies and stuff. So that's where all the pygmies are located. But it's an interesting island. The reason why it's interesting is because it doesn't have power. It's no electricity. There are about 40% mobile phone penetration. So you might be wondering, when there's no electricity, what is the use of mobile phones? Yeah, even I keep on thinking about it. But the smartphone penetration is around 2%, right there. People do not have bank accounts. There are no banks. So anything to do with trading, people have to travel either to the DRC island or to Rwanda, right, on a boat, which takes about probably around an average of 6 hours, right? So this is what you see. So if you want to go to the island, and visit them. It's going to take you about 6 hours on a boat, nice boat, diesel powered, and obviously the roads are like this. There's no infrastructure, basically, right? But people there live happily. It's one of the most beautiful places. As I said, it's also known as a forgotten island because no one knows about it. Most of the people there rely on farming, especially there's a lot of coffee plantations, and also tungsten mining is something which is very popular there, right? But one of the biggest issues at the moment is basically people who have to trade have to travel on a boat, and many people die. And so there are many single moms out there. So the king and the queen there have been trying to look at solutions of how to solve some of the problems that have been plaguing this island, right? And they are open to look at new technologies. So one of the things they actually wanted was to come out with the affordable internet access, because at the moment, obviously, there's no infrastructure, there's no grid. There are only two hotspots for mobile signals. One is from Airtel DRC, and the other one is from MTN Rwanda. So that means, like, even if you're accessing your GSM, you're actually paying roaming charges, right? So the data bundles is around about $40 per month. And that's very expensive for people right out there, right? So just imagine how this island would change when there is technology in there, when there is internet connectivity, when there is cellular connectivity, right? With the advancements that has happened in Africa in terms of mobile payments like M-Pesa and all the others, right? Things will have a different perspective, right? But unfortunately, this is not just on IJWI. This is applicable to most of Africa as well as other emerging markets or the least developed countries, right? At the moment, there are about 4.1 billion people without internet access. That's more than 50% of the global population are without internet access, right? And it's not just internet, it's also other essential utilities like the grid, the electricity. There are about 1.2 billion people without electricity, as well as 2.2 billion people without bank accounts. And obviously, I was reading yesterday, there are about more than 2 billion people without toilets, right? So this is a fundamental problem that needs to be solved and addressed, right? And what is common among all this? It's basically, you see, it's the same old countries, right? They lack essential infrastructure. But my talk is mostly focused on the internet and its impact on the bottom 1 billion people, right? There was a recent, not recent, in 2014, there was a study by Deloitte, commissioned by Facebook, that kind of clearly shows where they have studied. They say that if emerging markets, if you improve internet access to percentages that what we see in the developed world, these are the sort of benefits you get out of it. We talk about 2.2 trillion in additional GDP growth. You can create almost 140 million jobs, enhance productivity by 25%. But most importantly, internet access can actually save 2.5 million lives, right? So you might be wondering why, what has internet access got to do with lives? But there is evidence here that shows that you can actually start saving lives of people because of the knowledge, because of all the other essential access you would actually get by having internet access infrastructure, right? Is it clear? Yeah? Oh, interestingly, so let me ask some questions. Do you know where this is? The middle? I thought Jonathan would say. So it's in Nepal, right? So basically, this is how older senior people actually go for their regular health checkup. It takes them almost 2 days for them to travel to the local health clinic to get them checked, right? Because there's no roads, right? And that one on the left is also again in Nepal. That's how kids go to school. And this is in Thailand. And this is how kids go to school, right? So that is a pertinent problem that needs to be solved, right? I'm not saying technology is the answer to solve all the problems, but it could be a potential solution to solve some of the problems that you see here, right? So what are the challenges of internet access provisioning? Why why do less than 50% of the population only have internet access? One of the fundamental problems that's well known is geography, right? I mean, like if you want, I think you were talking about it just now, like if you want a mobile operator or a standard broadband provider to come and put up infrastructure, they want to make money out of it, right? So they look at what their capital expenditures are, what their operating expenditures are, and then they go and roll out infrastructure. If they don't make profit, they're not going to do anything. Simple as that. So in many emerging markets, people earn less than $1 a day, so there is no incentive, financial incentive, which is right there. But also in places like rural Scotland and other places in Europe and other developed markets, especially here in the USA, as well, people who live in rural areas, you're not going to get a mobile operator to come and put up an infrastructure, a cellular tower, or a broadband provider coming and putting up a fiber infrastructure. No way, right? Because they're not going to make money. You can't blame them, right? Obviously, in places like Africa, in a continent like Africa, regulation has to play a major role, right? Because you have most markets that are like monopolistic and oligopolistic markets, which are controlled by states and stuff. So the cost of accessing infrastructure, since there's no competition, is high, right? So in some countries in Africa, the cost of accessing mobile broadband is almost from 40% to 100% of the average national income. That's expensive, right? So apart from the geographical, economical, and the regulatory challenges, you have this issue of social challenges. People don't see the value of the internet, right? And one of the main reasons, because obviously they don't have an infrastructure to know what the internet is about and to taste its benefits. But obviously, most of the content in internet is in English and other major foreign languages, right? And there is no local content for people to actually adopt internet access as a technology, right? And you cannot have that since you don't have an infrastructure. But this is also a chicken and egg problem that I'm going to talk about later, is basically if you don't have infrastructure, you don't have local content. And since there's no local content, there's no adoption, people don't want it, and hence there's no infrastructure, right? So where do you start? Is an interesting problem. And obviously skills. Capacity building is a very, very important problem that needs to be, oh, sorry, there are sandwiches. Shall I open the door? Oh, okay, right. This time. Right, so capacity building is always a problem. You could go and teach people in rural villages to put up infrastructure and manage it. But what do? Once they learn, they go back to the cities to make more money, right? So maintaining infrastructures and managing it and training people is always a major challenge. So there's a whole lot of interesting challenges that needs to be solved. It's not just a technological problem, or you cannot solve this by just technology, right? So you have to address it from different angles. Right, so the next set of slides is I'm going to kind of talk about several initiatives that's currently going on, some in which I'm also involved, when some other, there's been a lot of work others are doing as well in this space. And I'm going to just I'm just going to summarize some of the activities. So we go back again to Ijwi in Democratic Republic of Congo. Together with Ensemble pour la Défense. Ah, yeah, right, it's French. Right, so it's a social incubator based in the UK, but they incubate several projects in the island, in the Democratic Republic of Congo, especially in the island of Ijwi. So Ensemble has been working with the king and the queen in coming out with new innovative projects that could actually benefit the island. One specific project is called the Pamoja. Pamoja in Swahili is together, right? So what we've been working on, Jon Miller is the main guy who actually runs the project, who's in the middle there with a beard, a nice guy. Together with some of the local people, we tried and put up an infrastructure, a wireless infrastructure for the first time in the island to connect the people, right? So at the moment, we've connected, we have 3 masts, wireless masts, and 3 locations where we've actually started providing broadband access. And when I say broadband, it's less than 1 megabits per second because our backhaul is about 2 megabits per second, right? And we are paying about $400 a month, right, for 1 Mbps. So if it is 2 or 3, you pay more and more, right? So I'm actually talking to Avanti, who owns, who's currently providing a Ka band coverage across Africa, and they are happy to support us, but we are working on that. So at the moment, once we put up the infrastructure, we have about 300 users actually using the network. So this is in a local center. It's like a cafe, internet cafe, that we have put. So you have 300 users coming in, and some actually walk up to 15 kilometers every day to come and access the internet. Right? 15 kilometers. You're not going to get a heart attack or a diabetes. Right, sorry, yeah?
Are they actually walking 15 kilometers to access the internet, or are they walking 15 kilometers to be within a community of people who they're interested and close to?
I think it has a link. It is correlated because the hotspots are bringing communities together. So there is some sort of social cohesion that's happening at the moment. So people kind of come here together. So there are other benefits. Obviously, there might be business interests and different things. That one looks more interesting. So yeah. So it's about the community cohesion forming out because there is an infrastructure there. And as some of the surveys that we have done kind of show that internet is actually an essential utility, right? Someone says, without the internet, without life, right? Yeah, nice. No, I was just thinking what happens without wife. All right, but anyway. So as I said, our hotspots have brought the community together around the location. So that's good. I've kind of actually removed something. At the moment, it's not about broadband infrastructure. We are also trying to provide cellular coverage. So we are actually working with a major organization, which I cannot name, who are actually working in the space of open source cellular base stations. And with them, we've actually now started doing deployments across the island, trying to connect all 300,000 users to GSM connectivity. And obviously, it also has, oh, thank you. Do I look tired? No. Obviously, it also has potential for moving from 2G straight into 4G. So that means 300,000 users over the next 1 year have access to 4G LTE connectivity, right? So these are some of the projects that's been going on. This is another project. This is also a community project. This is run by Ubuntu Power, which is a social enterprise based out from the UK. So I'm also part of that. So here it's a different model. This is in a village called Mutaroni near Mount Kenya, about 4 hours north of Nairobi. And in this village, the model that is being followed is basically the company Ubuntu Power is actually taking essential utilities in one single container. Right? This is not Docker containers if you're a computer scientist, right? But these are like those physical containers, the old containers, which has solar panels and all the other essential utilities to provide both off-grid electricity as well as internet, as well as also they say water and other stuff. And so this is an interesting deployment site. So the container is right there. You have the solar panels that is providing off-grid power. And then you have a satellite dish that has the backhaul, and then you have a Wi-Fi mast that's actually providing broadband. So the model here is to offset the cost of providing electricity, they are actually providing internet access so that can actually cross-subsidize the cost of providing power, right? So that's the model. But there have been a lot of interesting impact studies. In fact, we are actually working on it at the moment. So we are actually having a social scientist recruited there on the ground who's actually doing the studies. But some of the interesting impact of actually providing both energy and the internet is, this was interesting. The land value has actually appreciated 50% over the last 3 months. So people in Nairobi are now investing in that community because there is infrastructure, right? So they see that there's going to be value in those lands. And obviously, I have some pictures which I haven't put up. There is a new barber shop, restaurants, and also there was this gambling site that has actually popped up. Yeah, so there's a lot of interesting stuff that's happening on. You can kind of say, like, once an infrastructure, a utility comes to a village, you immediately start seeing things that completely transforms the village, probably for its benefits, right? So this is one example. So in a continent like Africa, I personally, maybe I'm open to suggestions, I kind of personally believe those sort of models where you have a community-owned infrastructure and community-owned business models is the right way to go forward. Because you cannot have operators putting up infrastructure. So what do? You have a local entrepreneur or entrepreneur from outside coming in, putting up infrastructures and making a business out of it in a much more lower, providing more low cost. And I think that is much more sustainable compared to any other models, right? So that is why you kind of see that in places like Africa, you have different providers like wireless internet service providers and other community-owned infrastructures coming up at the moment. But if you look at the Europe, as well as also USA and other places, there is this new, not new, probably over the last 10 years, there's this initiative called community networks that have sprung up. So community networks is basically communities getting together, putting up an infrastructure because no one else is putting that, right? So they get together, they try to solve the problem, they put up the infrastructure, they manage it, and they maintain it, right? It could be for, I mean, it's not for profit, by the way, right? And there are different types of community networks. So as I said, community networks is built, maintained, operate, and owned by communities of citizens. It is open to encourage participation. It is neutral and free from any discrimination, right? So when I say free, it's freedom, not free, right? And compared to current conventional telco models, CN models are much more fairer, more inclusive, more participative, and more sustainable. So let's look at some examples of community networks. So one of the most famous ones is called Freifunk. Do you know where this is? I haven't put. Where is Freifunk? 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 Good. It's in Berlin, right? So obviously you might wonder, in a place like Berlin, obviously there is internet, there is infrastructure, people have money and stuff. But a group of practitioners got together and they actually wanted to just play a game. They just wanted to see, how do you actually share your Wi-Fi with your neighbors? How can we all join forces together actually to create a network? It didn't actually take off when it started off in 2003, but off lately, it took off, it's growing exponentially. Do you know why? Because of the refugee crisis. Because of all the refugee influx, these networks are the ones which are actually providing broadband connectivity, right? And frankly speaking, it could be classified as it could be classified as the largest community network in the world. Even though WiFi claims that, which is next I'm going to talk about, but it has about 100,000 plus wireless nodes, right? So basically, how does that model work? I have broadband at home. I open up my Wi-Fi access point for anyone to access it. So everyone does that, and what you create is an ad hoc mesh network similar to what the RoofNet, which turned into Meraki from MIT, right? So it's a similar thing. You are talking about RoofNet. Yeah, so that's the sort of model. And why is it successful in Berlin or in Germany? Could you do the same thing in the UK? It wouldn't. Because in many countries, you have issues of secondary liability. That is, I cannot share my broadband I can't open my network to anyone to access it. So what happens if someone uses my broadband to do illegal stuff? Obviously, what you have, you don't get their IP addresses, you get your public IP address, right? And you are in trouble, right? But Germany is awesome. They don't have the issues of secondary liability. They don't care. So they've removed it, right? So I think along with Sweden? France too. Okay, France, great, right? Yeah, blame Brexit. But the model, like because there's no issues of secondary liability, people can open up the network. They don't care. You can do whatever you want, right? And it has been successful, considering everything is free there. There is no governance model. There is no business models, nothing. Just open up the network, use it. 100,000 wireless nodes connected as a mesh network. Stunning, right? This is WiFi.net, with whom I'm involved personally. So, do you know where WiFi.net is? Can you see from the map? Apart from France, right there, down there. It's in Spain. It's in Barcelona. I shouldn't say Spain. It's in Catalonia, right? So again, it's the same story. A group of people got together because the rural villages in Barcelona were not connected. The operator, the famous operator Telefonica, didn't bother to connect them. So what they did, joined forces, created wireless mesh networks together as a small group, and over a 10-year period, it has exponentially grown, right? It has about more than 30,000 active nodes, right? Inactive, I mean, in total, that'll be about more than 45,000 nodes, but active nodes, 30,000 nodes, connecting 100,000 users, more than 100,000 users. And it has grown to a fact that it's now a community network. So there's a network infrastructure that is governed by the commons principle. Do you know what the commons principle is, right? Like Alstrom's principles of the commons and stuff, right? So basically, anyone can actually, you are all part of the network. You all govern. You are all part of the governance model. But you also ensure that you don't have the tragedy of the commons, right? So you don't deplete the infrastructure. So for that, you have an economic compensation system that ensures that whoever puts the infrastructure is also compensated. And whoever uses it pays for it, right? So interestingly, there are 18 points of presence. So that means you have multiple operators now running on that network, providing services to the internet and other services. And the capital expenditures per annum is about 7 million euros. The operating expenditures is, the capex is 7 million euros, more than that. But the opex annually is nearly 3 million. Maybe I just bullshitted here, but it's fine. But the interesting aspect is, one of the main reasons WiFi.net is so successful is because, again, the social cohesion. People trust each other, and they are happy to work with each other to put up the infrastructure, right? And not only that, it's people's love for technology. So here is like this monthly meetings where people all turn up, talk about technologies, new technologies, what do you adopt, how do you do it, right? And that's one of my postdocs sitting there. He's trying to go and do some deployments there. So he's trying to convince them, saying that let's do these deployments. So he's trying to do that. And obviously he's posing there. He knows that a picture is being taken. So he looks serious. But yeah, so these are the people. Like you can kind of see that they love technology. They know about routing protocols. You don't expect that from some rural, you go and talk about OLSR v2 or Batman Advanced, and these are all routing protocols and BGPs and stuff. They know that. They know about 2.4 gigahertz, 5 gigahertz. They know about all that, right? That's amazing. You talk about antennas, they know that, right? So people are geeky. People want to learn technology and adopt it. And obviously, WiFi as a foundation has built governance tools, like technical tools to kind of visualize how nodes are connected. So that is one network, one small network where each of them are interconnected. And there are several other models, but also there is a very strong compensation system that kind of tells you who is using the infrastructure, how should they be compensated, etc. So these are the reasons why WiFi.net is famous. It has been successful. This is in Barn. This is in UK, right? In Lancashire, right near Lancaster. BT, which owns the largest fiber infrastructure in the UK, didn't bother about putting up an infrastructure in this rural place, right? So again, you have the same story repeating. Communities, group of people trying to solve, let's connect the villages. But here, they are not using wireless technologies. They have gone a bit more further. They said, let's put fiber broadband everywhere, right? And what you see now is Barn has the fastest broadband, fiber broadband in the UK, connecting 4,000 households in a rural villages in Lancashire, right? At £30 a month. And they have a very interesting business model. So it's basically everyone who's part of the network is part of the cooperative, right? And they own shares. And obviously, as a return, after 3 years, they get 5% return out of it. They can shell back the shares at £1 each from what they bought to the same barn. They can't sell it outside. But that's the sort of model. So everyone is part of the cooperative. So everyone owns the infrastructure. So if you are a rural farmer right there where the fiber broadband is going to go through, you also become a shareholder because you're donating the land to that. That's how they make the money. That's how they are sustainable, right? And you might actually think that the people who put up this infrastructure might be 18, 20-year-old Mark Zuckerbergs. No. It was this lady who started that, who's a retired hairdresser, who had no idea about technology, right? So Chris here, she's the one who actually started up this initiative, right? And those are the people who actually run the network, right? So age doesn't play a role here, right? It's not the youngsters. It's not about the youngsters. So anyone can actually learn new technologies. They adopt it because there is a reason for it. They need it. They see the value of it. Yeah, so they are rolling out a lot of fiber there. Oh, in fact, there are about 30 employees at the moment. So I visited them last week. Was it last week? No. Yeah. Right. So community networks is a very, very interesting take on solving this whole broadband connectivity problem globally, right? This is just from a map from the ISOC. There are several community networks out there, several initiatives, right? I think more than 100, right? And some of them cannot be even shown because of all the legality issues. There are many operating undercover, right? There are initiatives that are using cellular community GSM like Rhizomatica in Mexico, where they're actually providing community GSM connectivity and stuff. So there's a lot of work that's happening. So this is just a global map. And actually, I was talking to the Internet Society folks, trying to kind of really map out and have a proper map, kind of showcasing all the community network initiatives that can be shown. Right. So you might be wondering, as a computer science researcher, if I am, why am I doing all this? This is just deployments, right? But one of the interesting things from an academic perspective, even though I'm going to leave academia soon, is the data that you can actually get from this sort of initiatives. Data that is really unique, that can give us unique insights into a lot of things. So I'm going to talk about 3 specific projects, just summarize them. I'm not going to show you a lot of graphs, don't worry, and I'm not going to bore you to death. You will see that these sort of results is something which you might not really see on a regular network if you had actually done deployments. So one of the projects which I initially started was called the Public Access Wi-Fi Service Project, the PAWS project. So this is a project with a whole lot of partners, including BT, Nottingham City Council and stuff. So what did we do? The thing is, we went to a very deprived area in Nottingham. You know where Nottingham is? Do you know Robin Hood? Good. Right. He's from Nottingham. There's nothing else in Nottingham, right? Apart from Robin Hood. I'm being recorded. Yeah. Okay, so Nottingham is a city with 300,000 population. We went to a very deprived area called Aspley, which has about 16,000 population. It is so deprived, right? It's ranked actually bottom 10% nationally in deprivation. It has an unemployment rate of more than 10%. And most importantly, it has the highest teenage pregnancy in Europe. And this is what happens when you don't have internet access, right? You have nothing better to do. You have nothing else to do, right? So we went to Aspley, and we actually did a war drive. So war drive is a mechanism where you drive around or you walk around collecting information about the wireless networks there, right? So we did a war drive, and we found out there is infrastructure, right? Looking at things like Sky and Virgin, which is a fiber broadband provider, which is about 21% and stuff, there is broadband in internet infrastructure, but there are people, there are almost 22% of the population don't have access because they can't afford to pay for broadband access. So what we did, idea was simple, similar to the Frey-Funk model, even though I didn't know Frey-Funk at that time, to be honest, is basically we wanted to kind of understand how can a user with broadband share his or her Wi-Fi for free with his or her neighbor who's not able to afford broadband access. What are the technological challenges? And what are the socio-economic implications of it? right? So that was a project. It was funded for 18 months by the Engineering Physics Science Research Council, which is the equivalent of the NSF in the UK. Right, so what we did, we went and deployed the technology. So we built our own router platform, the PAWS gateway, which opened up the network for people to use it. It was actually bridged to the home broadband. And then we actually had a VPN service to connect us to the management servers as well as the measurement servers. And we had the VPN server because we wanted to ensure the secondary reliability issues were solved. So that we know when a user actually accesses the network, he starts a VPN tunnel, so we know what the IP address is, and we can then account if he is doing something wrong. So we solved the secondary reliability problem there. Even though it doesn't really scale, the performance is issues. But from a technological angle, we also ensured that the sharer's broadband is not affected. So how do we do that? So we actually deployed quality of service techniques, QoS, to ensure that the sharers who's sharing the network had much more higher priority compared to the one who's using it. We also did a lot of measurement tests, measuring the broadband regularly to understand what the performance issues are, and we did a whole lot of other things. So we looked at things like availability. So if you go and put up an infrastructure, a set of nodes, is it online? Is it on all the time? So we wanted to measure that. We wanted to know how much unused capacity is there, so that people can actually share their unused capacity with people who don't have. And we also wanted to know what was the network being used for, right? And we did a whole lot of measurements. And I'm happy to talk about why did we use this, if anyone wants to know, right? So then deployment, so we went around. It was an 18-month project, but we took a whole lot of time to deploy. We went around knocking 2,158 doors, talking to people, trying to explain the project, right? Me and a bunch of social scientists went around knocking doors in Nottingham, right? And you encounter a whole lot of interesting things, interesting people. And obviously, we weren't insured, so it was, yeah. So we recorded responses of 730, and we ended up with 20 people agreeing to share the network, 54 using the network, out of which only 18 actually use the network. So I'm not going to go through all the results, but I'm going to specifically talk about 2 results that was very unique, that was interesting for us. So one was the availability. You expect when you go put up the infrastructure or the nodes, people agree to it, so that means it's going to be online all the time, but it wasn't the case, right? So you can kind of see that when you have the 20 routers across a 3-month period, is basically most of the routers were offline most of the time. So you don't get anything out of it. People can't actually use the network, right? Why was the most interesting things? Because there were cases where people actually switched off their home broadband during night times to save electricity. They didn't want to pay for it. It was surprising because all my electricals are always on, right? And I was assuming that would be the case. But people just switch it off, switch off the broadband because they don't want to use it. So when you don't use the thing, switch it off, right? There was another case where many cases where our routers were offline was basically we bridged our routers to existing home broadband routers, which had about 4 or 5 Ethernet ports. And most of them, they would end up plugging it for something else, and that means they remove the thing. So it goes up, so it wasn't offline, right? So one of the prime factors was, if you want to go and deploy an infrastructure like this from an academic perspective or from anything else, if you want it to be successful, you need to have some sort of incentives. So since there were no socioeconomic incentives for doing it, people just didn't bother. It was just a project for them, they didn't care, right? This was fascinating. When you go and deploy a wireless network and you look at usage, what do you expect to see? YouTube, right? Video streaming. But what we saw is unexplainable, right? We saw ads as the highest driver of traffic in our network, right? That's 60% of our traffic, both in terms of sessions as well as bytes transferred, was ads, right? So the majority of the traffic was this, because most of them were using free apps and stuff, and that was just opening up multiple TCP connections, pulling out all the ads and stuff. It was just ads, right? And this was not something which we saw only here. is also something which we saw in Thailand, which I'm going to describe. Right? So let's go to Thailand. Right? I know it's tiring. Right. So in Thailand, this is Professor Kanchana Sut. How many of you know her? Good. She is the internet pioneer in Thailand. She brought internet access to Thailand. She owns the .th domain. She runs the Bangkok IXP, and she is the figure there, right? So obviously, I've been honored to work with her. So Kanchana has been she deployed the first wireless mesh network in a community in Thailand. So I'm going to talk about that project, with which we also collaborated with. So here, we went straight to a community in the Tak province, which is a province right next to the Burmese border, right? It's absolutely fantastic, right? People eat fried frogs, bamboo, worms. Oh, lovely. Yeah. It's a bit of a task if you want to go and do some deployments there. But I got vegetable pizzas, but I didn't put the picture there. Right. So we went to the community. We worked with people. We spoke to people, trying to understand what their problems were. That's the village chief. And that's Addison, who's one of my main postdocs. He's from Thailand. He was with Kanchana before he joined my team. And so together, we went and put up a community wireless infrastructure, very small mesh network with almost 14 nodes using just standard wireless technologies. And obviously some walks for antennas, right? If you see that. So what was the impact here? In terms of the impact, we deployed the first community network in Thailand with a population of 300 users, which is a small village. We managed to reduce internet subscription cost from $28 to almost $5 per month, right? Because the backhaul costs were now amortized between the users who actually were part of the network. There were only 10 users actually using the network in the village. That increased to 200 by 2016. We trained local staff to actually run the network so that the AIT folks don't have to go and do the network. Seeing that there was a demand, the local ISP went and put an exchange right there because they wanted to actually put more additional infrastructure for backhaul, because they saw that there was a demand. Initially, they didn't bother, right? And Kanchana has actually now started a social enterprise called Net2Home, and she connects now more than 500 odd villages. But interestingly, NBTC, who's a Thai regulator, seeing all this efforts, has funded us a project to do the first TV whitespace deployment in Thailand to provide a backhaul connectivity to the village, right? TV whitespace is a new wireless technology. I can talk about the details if you're interested in knowing what it is. But what is exciting is empowerment, right? The joy of actually training these people and seeing people actually use the network, use devices, is fascinating. There are a lot of interesting stories. There was a school kid who used to walk from some village somewhere, come to a Buddhist temple, just take a laptop from the Buddhist temple for free, and he comes and sits there and does his homework during the weekends. That's the sort of impact. That's the sort of things you see, right? Obviously, we did some social studies to understand what people use the network for. And what we saw was, again, there was a lot of mobile phone usage with obviously Androids. But what was interesting is people actually used the internet for important content, especially local content, right? And from a computer science perspective, we've got some interesting insights. When we collected data to figure out what people actually use the internet for in the community, what we saw was this. There were 3 domains that came in that surprised us. Why? Because all those 3 domains are in Chinese. They are like Chinese things. And in Thailand, they don't speak Chinese. So how is that possible? How can it reach the top 10 domains that were visited? But when we looked at it very closely, what we found out was something like Baidu.com. People, their own cheap Chinese phones, they have a Baidu browser. And when you switch on the Baidu browser, it immediately starts spamming the network, collecting a lot of data, pulling out a lot of things and stuff. That's what we see. This is something that is really important if you want to solve the connectivity problem in emerging markets. Take South Africa, for example. Most of the things are like pay-as-you-go models. So you pay for a specific set of bandwidth, right? So the current way the applications and services are all architected, right, is from a developed market-centric thing, right? They think there is surplus capacity. So you don't really care about ads or ad traffic. But if you go and access the same sort of services in emerging markets on pay-as-you-go, you're just literally wasting all the bandwidth, right? And that's money, and that's serious money, right? So what is interesting is to kind of understand these sort of data for us to drive us in building new architectures. For example, how do you design much better edge caching systems? Do you just use something like LRU, least recently used? And if you had used LRU, what you would see is caching out services that are not actually needed. So you need to have a bit more context when you're actually designing new architectures. And this is helping us doing some of the work that we are doing in terms of research. Right, whew, I'm tired. Right, this is the last study that I wanted to show, which is also interesting. This is about, so I was talking about access, internet access. But obviously, it's not just connecting to the internet, it's about accessing the services. And Africa has this most fascinating challenge, which I'm going to talk about, right? And that was in some of the South African deployments. This is how technology is embedded. Everything is caged. Even the power adapters are all caged because someone would flick it if you just leave it like that. So it's a challenging environment, even to have infrastructure, host infrastructure. Next day you won't see it, right? So it's been a challenge. So this is a study that we carried out with Cisco, Queen Mary, and India Networks. What we wanted to know was, how is the web ecosystem provisioned for Africa, right? So what we did, I don't want to go into too much details. We did a lot of measurements. We ran a lot of DNS queries using things like RIPE Atlas probes and also eDNS client subnet probes. I can talk to you about in detail. So we ran DNS queries. We collected a list of Google caches because we wanted to measure how is Google providing connectivity or services to Africa, wherever the Google cache is located in Africa. So we collected a list of Google cache frontends. We geolocated them using 10 databases and a host of other techniques to ensure that there is no false data. And we did a lot of path performance tests. And what did we find out? We found out that almost 65% of the Google caches that serve Africa are not in Africa. They are located outside the continent. Most of them are right out in California, right? So there are almost 3,120 cache frontends that are actually serving Africa, but out of which 65% are just located outside the continent. And so what is the performance implications of this? So we did path measurement tests, latency measurement tests for all the Google caches, and this is what we see. Obviously, if a country owns its own cache, you have very good latency. And this is for accessing a cache in the US. That's the latency. A cache in Europe, and surprisingly, if an African country wants to access a Google cache in another African country, the latency of accessing the cache is much higher compared to accessing a cache in the US, right? So it has much more fundamental problems. What is the reason? It's because of how the internet service providers or the network operators are all peering with each other. There's a whole lot of things, dynamics, which is not just related to last mile access provisioning. You move from last mile access to backhaul, to core, and all the IXPs on how the network operators peer with each other. Most of the networks peer in Europe. It's much more cheaper, it's much more easier, right? And the infrastructures are much more reliable. Why? Because things like Google, Facebook, Twitter, all these things, all the data centers are all located somewhere else in Europe, right? There are no incentives for network operators to actually peer with each other, right? So this has implications not only from Google, but also if you're accessing Facebook from Africa. You can do this interesting ping test. When you go to Kenya and you ping Google and Facebook, you see massive differences. Google would have much more lower latency, whereas Facebook would have something higher, because Facebook doesn't have a cache right there. But the interesting result is it is not just global websites. Even local African websites, the latencies are high, very high, because most of the data is either located in Europe or in South Africa, where there's much more infrastructure. And for accessing South Africa, you have to go via Europe. You have the circuitous paths, right? So this is what the data gives you. unique insights, trying to understand what are the challenges, and then you come out with solutions to solve this problem. Okay? So all of this has actually led into some of the interesting stuff we are doing at our labs. So we are looking at building low-cost, multi-access edge computing platforms. For example, this guy actually hacked the Raspberry Pi to run 2,400 odd web servers running on a single quad-core Raspberry Pi. So you can actually run almost 2,000 odd web servers in a single Raspberry Pi. And obviously, if you have a cluster, you can do. I wanted to take it a bit further and exciting. What we did was, with a couple of interns in India, we actually built these quadcopters with Raspberry Pis. So these quadcopters can actually fly, create a mesh network, and these are actually powered by Raspberry Pis, all running things like Dockers or other unikernels, providing local services. So in an emergency scenario, when there's no network, you can actually fly them as a mesh network, and you can actually have a micro data center in the air. Right? So that was the thing that we did. I actually have a video if I can show you these flying. Right. So we are doing a whole lot of other things about looking at network centrality metrics and placing services and blah, blah, blah. But another aspect is we are also adopting new technologies, new architectures like NDN or the name data networking, the information-centric networking that's been coming out in the networking space. We've actually building these and actually started doing deployments off the ground in emerging markets and other spaces. Right, final set of slides. So as I said, 4.1 billion people are yet to be connected, and we saw that there were a lot of community network initiatives, and we need more. But how do you actually incentivize these networks, right? Without an economic substrate. Obviously, we saw that the social cohesion was an important game changer, but an economic incentive is also needed for networks to sustain. At the moment, networking technology is more about manual payments, and you have this whole lot of agreements and contracts and stuff, which is really cumbersome, right? So how do you come out with new technologies that can actually enable networks to be seamlessly deployed and to be much more sustainable? And that's where Amber comes in. So Amber is a new initiative, which I'm also a founding member. It's called the Autonomous Modular Mesh Blockchain Router. Has 3 components. So we are building probably an interesting thing where we are combining multi-spectrum mesh networks, right, with a micro-payment layer underneath so that networks can connect to each other and pay for the traffic they send or forward autonomously without any manual involvement. So networks can talk to each other, they can do business deals, transactions, and everything. So we don't have to do anything, right? So that is a sustainability angle. So that's the Amber node. And the beauty of the Amber node is basically everything is modular platform. So you have platters of these devices, you have storage spaces, you have computational capabilities, you have a multi-spectrum chipset that can connect you across multiple bands, right? And you have this entire micro-payment thing, which I'm going to talk about, right? So if you want to adopt a new technology, you don't have to throw the router off. You can just buy a platter, fit it. It's all magnetic. So as I said, we are actually building a chipset at the moment. We are going to start building, where we are trying to pack as many protocols, network wireless protocols as possible into one single chipset at the lowest cost possible, right? So imagine a scenario where you can connect from IEEE 802.AX to AH, which is like different ranges and stuff, TV white space, LTE in unlicensed bands. So we are trying to pack as many protocols as possible, right? Why is this important? Why is heterogeneity in network access important? Because of this. Do you know what this is? Facebook did a study 1 or 2 years ago that kind of showed an important finding, that almost 99% of the population are at least 63 kilometers radius of a city. This is a study from looking at 23 cities with the Center for International Earth Science Innovation Network. That kind of shows that if you have an access last mile technology that can connect you up to 63 kilometers in some way, some form, you can actually connect almost 99, you can reach 99% of the population, right? So that means there is no one single solution here, access solution. You're looking at diverse type of network technologies, last mile solutions that you want to bring together to actually connect and reach the people, right? And once you have the capability to reach people and connect them, what you need is something that is more sustainable. So that is why we are building this whole transit pricing mechanism into these routers so that I can have a network operator here, a community network operator who's putting up a few nodes, and another network operator putting up a few nodes, and these nodes can each talk to each other, and for the amount of data that they transmit back and forth, they do their own pricing, smart pricing, and exchange value, right? And for this, how do we do that in an autonomous, decentralized way? Comes blockchain. Everyone wants to do blockchain, so we also want to do that. But we also want to do that because there's a reason, right? So we want to actually enable this whole thing to work in a decentralized way, in an autonomous way, right? And so we are using a blockchain, underlying blockchain technology to do this. So where the entire configuration and transaction data are all embedded into the blockchain, right? And amber, the color, was actually the nature's original blockchain. Everything is immutable. If you had watched Jurassic Park, the mosquito was also on an amber colored thing, yeah? So that's why we named it as amber, thanks to Jurassic Park. Right, but you might also wonder, how many of you work on blockchain here? No? Good. So whatever I say is right. Okay, so do you know what Bitcoins? Yeah, you know Ethereum? Yeah, good. Right, so these cryptocurrencies and tokens, right, they actually use a consensus algorithm that is not energy efficient. It's called the proof of work, right? So it's basically, the consensus algorithm is based on, or you choose a block leader for deciding what your next block is, based on something called proof of work. That means you have to do specific set of computations that are highly energy consuming, right? It's too much of energy requirements, right? So you're burning electricity like hell, right? Obviously, people have come out with solutions like proof of stake and all the other proofs, but there are a whole lot of other issues. So in order to solve this problem, we have come out with a new consensus algorithm called the proof of elapsed time / proof of velocity. This is actually taken from, the proof of elapsed time is actually from the IBM's Hyperledger project, it's been used there. But we are taking that and we are adopting it and changing that to also add an extra consensus layer called proof of velocity. I'm happy to talk about what exactly the technology is if anyone is interested to know, right? So the blockchain, the consensus algorithm, will be one of the fastest, lightweight consensus algorithms that would be available for people to actually use, right? Now, when you're doing transactions, when you have devices doing transactions, when you're having users using transactions, how do you ensure trust in a decentralized way? And for this, we are looking at this concept of self-sovereign digital identifiers, right? Where every user, every device the user owns, everything would have a digital identifier through different attestation mechanisms. I can again talk about decentralized autonomous organizations, DAO, and there's a whole lot of technical jargons which I don't want to bother you about, considering I'm also tired, right? So we are looking at digital identity as a mechanism to solve this. We are also building devices that can actually hold your private keys and all the other stuff. Finally, what is more exciting is the Amber nodes has so much of computation and storage that they can actually act as micro data centers at the edges, right? So assume that you are a node owner. You can share your Wi-Fi with your neighbor or with the community. But not only that, you can also make additional revenue by leasing out your computational capabilities. So imagine for every Docker container that is run on an Amber node, you earn tokens, right? Or for every storage space you lease out using something like Filecoin or Storage, which are all decentralized storage spaces, you can actually do that. You earn more revenue, you earn more money, right? So you're building a new token economy. So that's the benefit that we see. So as I said, Amber, personally, I see it as a solution because you can have a lot of different models in how to deploy them and how to use them in such a way that you can actually have much more wide-scale adoption. And what is our ambition? Simple. We want to deploy the world's largest blockchain network focused on emerging markets. Why? Simple as this. The top one is the Bitcoin network deployment at the moment, and the bottom one is the Ethereum network deployment. So you have about 11,000 Bitcoin nodes. Ethereum is around 25,000 nodes as of today, right? But you see, places like Africa and others, there's no infrastructure, right? Considering that blockchain and specific technologies that are related to that has massive potential to transform communities, right? Just imagine this scenario of P2P aid delivery. You have Uganda, you have 1 million refugees in camps, you provide them with connectivity, you have this concept of digital identifiers that identify each and every single refugee, and you can have an attestation process from all the government authorities that kind of says that this person is a female, this is the age, this is the problems, etc., all attested, everything embedded into the blockchain, and you could have some sort of a USAID or anything profiling specific people to actually do aid delivery. So that USAID or any other UNICEF, for example, can come and say, I want to send this much money to this profile of kids so that they can go and educate themselves in a proper institution, right? And the beauty of the entire crypto token economy is you can actually program each and every token for specific purposes so that the kid wouldn't take the token and go to a pub. You can't spend it, right? It'll be used only for that. That is the power. Considering that all the aid can go straight into the person's account rather than having a third party. That's the benefit, you see. So some of the work we are going to do is deploy Amber nodes and create an Amber network in places like Ubuntu, like in Kenya, in DRC, and we want to bring in local banking, peer-to-peer banking, so that your relative in Europe can actually pay for your utility bills to a utility operator in an island in DRC using the tokens. No banks, nothing. No centralized authorities. Just change. This is radically disruptive. Finally, conclusions. So as I said, there is a massive problem. More than 50% are offline. So that means you have to look at multiple solutions to solve the problem. And emerging markets, personally and for many, it provides you exciting avenues for research, where you can actually trial out disruptive applications because there's nothing. You start, it's a green slate, right? So you just start off scratch. You can bring in new technologies. M-Pesa was an example. Ushahidi was another example, right? You can come out with new disruptive technologies. But obviously, from an academic perspective, it has potential for high impact research and obviously exciting stories to say. For example, this was in Thailand. Someone actually, the IoT sensors in the AIT, the Asian Institute of Technology campus, weren't working. So we drove to the community to see that someone had actually put their slippers on top of it. They assumed that's the best place to drive the slippers, right? Or this one is where, this is how they catch the crickets. So it's on a tube light, and they put an umbrella, and it's basically during the night times, and they also have a glue. When the crickets come, they get stuck on the umbrella, then they take it and fry it. And that's Addison, who was bitten by a dog when he was doing a deployment in Thailand. And he was getting his injections. And that's fascinating, right? Right, thank you. Thanks for listening. That's in Cape Town, by the way. Thank you. Questions? Oh, that'd be great. Thank you.
Now that we've given everybody sustenance, we have more energy. Interesting and insightful questions.
Yes, please.
Okay, so I will confess to having been tainted by having just read Ricardo Yokohama's Geek Heresy. And one of the basic tenets there is that technology is really just an exacerbator of a real requirement, which is on-the-ground, grassroots sort of community support. In most of the projects you mentioned, there really was this implication that there were people on the ground who really were getting community engagement stuff. And so I guess the question is, how do you scale that? Right? The technology is not, in some sense, the enabler, it's the grassroots stuff. And how do you scale that?
Right. So, as I said, like, as you rightly pointed out, like, if you don't have this whole community involvement or community cohesion that literally forms out when you have an infrastructure or a technology rollout, projects are bound to fail. So it's about communities really trying to understand and also actually seeing the benefits that actually comes out of a technology rollout. For example, like you saw in Ubuntu Power or in the GRC network by Ensemble or the Thailand network from Kanchana's team, is basically like when the internet access came in, you had students and others coming into places where there was internet access, getting together, having discussions and talking about it, seeing the benefit out of it, and then going back into their communities and trying to promote the need for internet access and coming out with probably even promoting some of the solutions that's been deployed on the ground and getting much more wide scale adoption. So in terms of even scaling, apart from this whole angle of having some sort of a sustainability in terms of economic angle, that is what the entire blockchain substrate could actually enable you to. It's about communities promoting the benefits of internet access to parents who might not have even heard about it or not used it, and then they end up using it. There were instances in the Thailand network where school children went to their grandparents' home and started talking about internet in general. And then they became adopters of the technology as well. So it is something that has to grow from a bottom-up grassroots level. It is something which we cannot really manipulate or change. Because like what we saw from some of the examples is that when you have one utility as a successful deployment, then you will end up seeing subsequent utility infrastructures coming out. And you will see that you will end up seeing that communities get together in one place, and that leads into migration patterns and economic investments and stuff. So it kind of changes, and it is going to be organic. So I don't personally see that we can kind of go and manipulate any of this to kind of speed up rapid deployments and everything. Yeah.
So my question is about, okay, I'm going to confess I'm a little bit of a blockchain skeptic.
Okay.
But, so the question is, essentially, what you guys are trying to do is establish this kind of informal, like a sort of a shadow economy on this like currency that you're basically making. And have you kind of thought a little bit about like the implications of doing that with like no like redistributive mechanism, for instance?
Sorry?
Well, it doesn't seem like there's a meaningful redistributive mechanism. Like if the goal here is to actually have this like shadow currency that like people are using, because like when you make something like blockchain, there's a sense in which like you're actually like building a new economy, right?
Mm-hmm.
And a problem with blockchain, potentially in the developing economy, is that the people who have access to these routers, for instance, are people with capital. Or how much are the routers costing, right?
Right. Okay. Good question. Okay. So it's time for marketing Amber.
Okay.
I hope they gave me more tokens for that, and it's on YouTube. All right. So no. So okay. Let's work the questions up. So each of these routers, hopefully within the next 18 months, is going to be around $50, right? Obviously, this might be expensive from an emerging market scenario. But the way we have structured it is these nodes will be free, deployed. And we will recover these costs, and also the backhaul operator will recover these costs through contract plans, like how you get a mobile phone and stuff. So that is how we will be reclaiming our cost backs. So we will be, but also it depends on specific use cases and specific deployments. There might be places where, like Cape Town or something, where people might be able to afford to. So we will have different business models on how we recoup the costs. The second thing is, Amber is not a currency.
Okay.
Amber is a token.
So you're not imagining people exchanging tokens for anything other than network
No.
It's a currency.
Okay, so no. So it's
Okay.
not only about internet access. Obviously, there's going to be a lot of services,
Okay.
so local services that will come out from an ecosystem will be developed when you have an infrastructure. We will be opening up the APIs for people to build new apps and stuff. So I cannot say what those applications are now going to be, but I kind of imagine there'll be a lot of decentralized apps that come out of it that will actually provide value to the local community, and the token, that is where the tokens will get exchanged. But not only that, we are integrating ourselves with utility providers, like the grid, the off-grid companies and stuff, where people can start doing smart metering and all the other stuff using the tokens. And obviously, the token will have an exchange, so we'll be listing out the tokens across all possible crypto token exchanges. But also there'll be local exchanges, so you can convert M-Pesa to tokens, and tokens to M-Pesa, or tokens to fiat currency, tokens to Bitcoins, cryptocurrencies, and anything, right? So utility providers can actually accumulate, get tokens, they want to make money out of it, they can sell it on an exchange, make money out of it, or they can actually keep it like any Bitcoin, Ethereum, assuming that there's going to be a value, because obviously there's going to be a market cap for the Amber tokens. I'm talking from an Amber perspective, right? So that is the thing. So it's about intelligently coming out with an ecosystem of services that is not just internet access or anything to do with the internet. It's more about building an entire ecosystem around it. Yeah?
Whatever reservation at Bangkok.
And
Yes.
I'm curious.
May I just interrupt? Sorry. May I say that my talk was entirely motivated by your charming, you were like, I was like, okay, I'm making sense. Yeah, I'm going for it. Yeah, please. It was a compliment.
First of all, I think this is total nonsense, right? But especially being in the area of ed tech and education, being online learning, which is more is going.
Sure.
I think it's great. But I always think about, just like for the people who are connected, you always have the bad players. And just look at the community, that was optimal, there's utopian, but I mean, I would think that something would be terrible if everybody in the community using it for positive things and somebody's using it for pornography or gambling. Well, I guess gambling's legal, but you know what I'm saying, for less than optimal uses. So you have any people off the network and
interesting thing. So this leads into a couple of things, right? The whole net neutral. So you're talking about, we are going into this territory of net neutrality debates here about, how do you prioritize access? Do you prioritize certain specific services? Do you control what people actually access the internet for? The easiest answer is Amber at the moment is not a network operator. We might become a network operator in Africa, where in specific communities. But at the moment, Amber is a non-profit foundation which will govern how the network should be run, but there are going to be people, local entrepreneurs who set up the network and set up their own specific rules. There are specific things that we cannot really solve, like censorship, internet censorship. So you go to Saudi Arabia, or you go to Thailand, or you go to Uganda, or you go to some specific countries where you cannot say that you can access everything. You have to abide by those regulations and rules. So we have no say, or we cannot control it. Obviously, when you have a decentralized environment, it's good. The game is going to change, because now we are talking about decentralized services without any centralized control. So that means I can start running local apps and services that might be away from what the governments are trying to block you for. Yeah, which is going to be a very, very interesting challenge.
Yeah.
Whether it is legally right for Amber to block them is something which is debatable, which we need to figure out, which we need to work out. But we have mechanisms inside the network using ideas of smart contracts and decentralized autonomous organization models that will ensure that any players or any nodes that are misbehaving will not be able to function or be part of the consensus system. We will be able to pull them out. That is how we are actually building the thing. Everything is autonomous, but we are building those smart contracts and decentralized autonomous organization that will govern that.
All right, let's thank our speaker.